Class, welcome to our first video of Chapter 3, where we really just focus our attention on quadratic functions, okay? So hopefully some of this is a little bit of a review for some of you. If not, please make sure to watch the video closely, and yeah, we'll figure this stuff out. So, when we have quadratics, the standard form for a quadratic is always this. And we've talked a little bit about this recently. We say it goes in descending order of the degrees. So something like that, right? ax squared plus bx plus c. This is standard form. We also, well, we haven't talked a ton about it, but we have been using this quite a bit recently. Have vertex form, which is ax minus h squared plus k. Okay, the squared is what makes it a quadratic. Okay, we know it's going to be x squared. But really, what we're looking at here is the h and k value, okay? The h and the k value gets you your vertex. And then what's really nice is the axis of symmetry. We always know the axis of symmetry for a parabola is going to go right through the vertex. So think about this with me. If I have a parabola opening up, right, something like this, my axis of symmetry is going, and it's going to be an x equals. It's just going to take whatever the h value is of our vertex. So these go hand in hand with one another. The last one that we maybe haven't talked a ton about, but hopefully you guys understand when we look at it, is factored form. Okay, f of x is equal to a times x minus p, x minus q. This hopefully makes sense. This is factored, right? This is one factor, this is another factor. Here's a coefficient, which is important, but yeah, this is factored form. And we know that the intercepts are going to be at p comma 0 and q comma 0. All right? So that was a quick rundown of the different forms we can see. Let's think about this. Which form would be best for graphing? Well, I want you to think back to last chapter. What were we graphing from? Which one? What looks familiar? Vertex form, right? We've seen these before, where you have a horizontal shift, a vertical shift, maybe a vertical stretch. This is what is easiest to graph from, okay? Vertex form. Which form is easiest to state the y-intercept? Well, that might be hidden, or maybe you guys remember from previous classes. That's standard form, and the reason is because it's very, very easy to just plug in 0 for x, right? Y-intercept means that x equals 0. Well, all of these other ones have a bunch of work. Like if I have to plug in 0 or plug in 0, this is nice. If I plug in 0, this goes away. If I plug in 0, this goes away, and you're just left with your c value. Okay, so the easiest for y-intercept is standard form. Lastly, which form is easiest to state the x-intercepts? Well, we already know that. Factored form. So a lot of this video, at least the next couple of problems that we're going to practice, are how to turn or how to change from standard form to vertex form. Because again, we want to be able to graph. We want to be able to graph. So to do this, we have to complete the square. I'm hoping that you guys have heard of this before at least. I do it a little bit differently than Miss Braytek does, so if you want to see how she does it, you're more than welcome to watch her video, or I could try to teach you guys in class. But what I basically do is, I start with my original. Okay, so I'm going to rewrite. And the first thing that I do is I move away my c value, okay? My goal here right now is I want to get the first two values of a perfect square trinomial together. And to do that, I have to move my c value to the other side. So I'm going to start by doing that. Oh, I didn't even do it. Minus 5 equals 2x squared. Okay? Now the next thing is, we can't, or it's harder to figure out what to complete the perfect square trinomial when there's a coefficient. So similarly to what we did when we were saying that we had to find the horizontal shift or whatever, I need to factor out whatever's in front, or my a value basically. Okay, so that's going to look like this. I'm going to factor out this a value from everything on the right side. So 2, which leaves me with x squared plus 4x. Now, what I want you to notice here, a perfect square trinomial, we learned about these at the beginning of the year. There are 3 terms, they're trinomials. So basically what I'm going to do now is I'm going to add something on the right side to make whatever is right here a perfect square trinomial. So that's going to look like this. And what I tend to do is I put a blank in here so I know that I have to add some number. But what do we know? If you add something on the right side, you have to balance your equation, okay? Which means I'm going to have to add something on the right side as well. Alright, so I add blanks to both sides. Now, there are multiple ways to figure out my value that I'm adding. You guys just might be getting good at perfect square trinomials and understand how to see this. The easiest way for me to explain it is that you always take half of the b value and then you square it. So you take half of b and you square. So 4 over 2 is 2, 2 squared is 4. Now, do not just blindly put a 4 right here. You have to be very careful. This 4 is being added, however, it is inside of parentheses, correct? It's technically being multiplied by 2. If I went and distributed, this would not be a 4, this would actually be 8. So that means I have to put 8 on the other side. Now I can continue. Well, this is f of x, what do we have, plus 3. This is 2. And this is the whole idea, guys. The whole reason that we did this is because we know if we have a perfect square trinomial, it always turns into a binomial squared. A binomial squared. So I know I'm going to have x. I know I'm going to have squared. We have to figure out what goes in here. And really, guys, there's 2 ways to think about it. You can either take the first part, the 4 over 2, whatever you got when you did your division by 2, that'll work. Or you can take the square root of your c value, and that will also work. They should be the exact same. So plus 2. And then lastly, I finish up by bringing back my 3. Okay, so now I am in vertex form. Hopefully we agree my vertex is at -2, -3. Okay, be very careful. If you noticed, and I maybe didn't talk about it enough at the beginning, my vertex form, notice that the h, it's minus h. That means that I'm looking for the opposite of whatever it looks like, okay? So if I see a positive 2, that means that I'm actually looking for a vertex of -2, at least for the x value, okay? Y is the same. This should be familiar from last chapter. Which means my axis of symmetry is going to be x equals -2. I know that I have a positive a value, so is this going to open up or down? Up. Alright, we're ready to graph this. Let's do it. -2, -3. Let's see, my 2 was the vertical stretch, so instead of going over 1 up 1, I'm going over 1 up 2, over 1 up 6. And that's pretty much all I can graph here. So something like this, something like this. You guys know the transformations. You could have used the transformations from the very beginning, from right here. You knew that this was a vertical stretch of 2. We went 2 to the left, and we went 3 down. Okay? Okay. So what I would like to do now, shoot, I don't know if that was off. I'm going to leave that up for a second so you guys can see. What we are going to do now is, people might be finishing up writing if I didn't show you what I was writing on the right. We're going to write some steps, okay? We're going to write some steps for what we just did. So as we flip to the next page, Steps to complete the square. I'm going to actually write mine right here because I do a couple more steps than Miss Braytek. So I'm going to say the first thing I want to do is I want to move the C value. Okay, that's the first thing I do. Okay, I move my C value because I want to get the first two terms alone, the first two terms of the perfect square trinomial alone. Okay, so I move the C value, and then the next thing I have to do, I have to factor the A value, if there is one, right? If it's just one, then you're fine. But if it's anything else, I need you to factor the A value from the remaining terms. Okay? The next thing that I do is I add blanks to both sides. I know I have to add something to both sides, so I have to add blanks to both sides to balance my equation. And then what I do is I complete the perfect square trinomial. Okay, that's where you get the name from. You're completing the perfect square trinomial. Okay, so to do that, what did we do? You half and square the b value. All right, you half and square the b value. So that is something that will always work. Once you've done that, you have to make sure that you where am I at? Oh, sorry about that. Okay, now you turn the perfect square trinomial into a binomial squared, and then lastly move back the new C value. Okay, so those are my steps. Complete the perfect square trinomial, half and square the b value. Remember here, I want to make a note. Be careful to watch for the A. Be careful to watch for the A. What do I mean by that? This is where, when you're adding that piece inside the parentheses, when you add to the left side, you need to make sure that you take into consideration the A value. So let's take a look at another example and kind of figure that out. All right, so we have another complete the square. First thing I do is I'm going to move my 1 away. So I'm just going to start f of x minus 1 equals negative 3x squared plus 6x. All right, so that's my first step. Next thing I do, minus 1 equals negative 3x squared minus 2x. Okay, now I add my blanks. Okay, I add my blank spaces. We have to figure out what's going to go in there. Okay, well, how do we do it? We take half of b and square it. So half of b and squared. Well, negative 2 squared. Oh, sorry, half. Wow. Negative 2 divided by 2 is negative 1. Negative 1 squared is positive 1. Now be very careful here. This is not just adding 1 to both. You're actually subtracting a 3. Okay? So now we can continue on. F of x minus 4. And then remember, the whole reason that we complete the square is because we can change a perfect square trinomial into a binomial squared. So x, what happened when I took half of negative 2? Well, I had negative 1. So negative 1. Very last thing, f of x equals negative 3 x minus 1 squared plus 4. Okay? So we now know that our vertex should be right at 1, 4. What else is nice? We know that our axis of symmetry should go right through the vertex, the x value that we care about, so x equals 1. We know that our graph is going to open down. How did I know that? Because our a value is negative. It's going to be a flip over the x-axis. Domain range increasing, decreasing, we should probably graph to take a look. So let's take a look. Let's see, 1, 4. I have a stretch of 3, so instead of going 1, 1, we're going 1, 3. And instead of going then 1, 3, we're going 1, 9. 9. So 1, 6, something like that. Okay. So there and there. And then you can sketch. All right. Now, the domain and the range. Domain. Hopefully we can agree. This is going left forever and right forever. I know it doesn't look like it, but we know that if there's arrows, it's going both directions forever. So negative infinity to infinity. Range, a little different. We now are looking up and down. So we're starting at negative infinity, and we're going all the way up to 4. So negative infinity, we have a closed point at a y of 4, so we bracket it. Now, increasing, decreasing. If I draw in my axis of symmetry, something like this, I can see that I'm increasing on the left, I'm decreasing on the right. So my increasing should be from negative infinity all the way to 1, and then decreasing should be from 1 to infinity. And remember, if you remember from when we taught this, we like to use the square brackets with increasing and decreasing. All right. Let's see here. I want to do one more completing the square because I want to show you what happens. This is going to be a little bit different. Okay, so I move over my 1. I'm going to factor out my a value. Okay, let's see what happens now. I'm going to add my blanks. What I want you to see here is this is going to be a little messier than our other ones. And why is that? Because this b value that I have is odd. Okay? It's the same exact steps, it's just you have to be able to work with fractions. That's really as simple as it is, okay? I'm still doing the same thing. I'm taking 3, I'm dividing by 2, I'm squaring. Well, what happens when I square 3 halves? If you guys remember your exponent properties, you square both the numerator and the denominator. So this is 9/4. So I have to put a 9/4 here. I don't know if you can see that. I feel like I need to write this better. Hold on, let me write this bigger so you can see. 9/4. That's 9/4. Now, when I go to plug in my other blank, remember that I don't have 9/4. I have 2 times 9/4 being added. So I need to take 9/4 and I need to multiply by 2. Please remember, this is just multiplying fractions. You multiply across, or what you can actually do in this case is nice. Simplify a little. This is 2 and 1. So what do we have? 9/2? Yeah, that's even easier. 9/2. 9/2. So when I clean this up, f of x, well, 1 is kind of like, or sorry, -1 is like -2/2, right? If I get a common denominator. So I'm going to actually just rewrite this. -2/2. -2/2 plus 9/2 should be positive 7/2. Now over here, again, remember, you don't have to do extra work. I want you to remember that whatever goes right here is always going to be half of your b here. So this will just be 3/2. Lastly, we move we move our k over. Okay, I'm going to change, oh my goodness, -7/2. That reminds me that I should not be calling this c. This is the k value. I'm so sorry for that, guys. So sorry. Hopefully you all already understood that and had that. Okay, why do I care about this? Because now I know the vertex is at -3/2, comma, -7/2, and my axis of symmetry is at x equals -3/2. Okay, now we're going to do one more problem. I'll save one for class. At the very top, hopefully we remember and are starting to become used to writing it. F of x equals a x minus h squared plus k. Okay, vertex form is always going to be that. Now, determine the quadratic function whose vertex is 1, -3, and contains the point 3/5. This concept, basically what I want you to understand here, I'm giving you an h and a k. I'm also giving you an x and a y, which means all I'm missing is a. We need to find the a. We don't know right now if a is 1 or 0.5 or 100, right? Like, we have to solve for this. So it's really as simple as rewriting your formula, or form, I should say, and then plugging absolutely everything in. I know that this is going to be 5 from the point, right? This is x and y. I know I don't know a. I know x is 3. I know my h value is 1. And I know k is -3. So really, it's very simple. You just plug everything in and you start solving for a. So 5 equals a. This is going to be 2 squared minus 3. Keep going. I'm going to change this to 4a. I'm going to move my 3 over. And I'm going to say a is equal to 2. All right? Please make sure that you understand. I know I went quick there, but hopefully the algebra works out and you guys understand it. The last thing, we want to determine the function itself. So the whole idea here now is to rewrite the function how I would want to see it to graph it. So x minus 1 squared minus 3. Okay, this is my function that has a vertex of 1, -3, and will go through 0.35. And to do that, let's check. So 1, -3. I now know that a value is 2, so I can use my growth pattern of 1 over 2, or sorry, 1 up 2, up 6, up 6. I graph it to check. Sorry, not the best line. Let's do that a little better. And what happens? It goes through 3, 5. Okay? So I'm going to stop there. I think what we're going to do is we're going to start by working on our last example in the next time I see you, which might be a while because of different things going on at school. So hopefully now, excuse me, hopefully now after this video, you are feeling better with completing the square, and you're figuring out which form you want to use and the different procedures for completing the square, and then also being able to write an equation of a quadratic in vertex form. I hope you guys have a great day. I'll see you next time.